Assalamualaikum and very good afternoon.
And Doctor.
Okay. I'm going to start straight away because last week we already missed one class. Okay. So today we are going to start with chapter 3, experimental errors and statistics. Okay. So for starts, we know that measurement and readings last time it depends on what type of apparatus or instrument that you use. So for example, if we use 50 milliliter burette with 0.1 graduation, readings must be nearest to 0.01 milliliter. And if you are using a calibrated millimeter ruler, readings must be to the nearest 0.1 millimeter. So what about others? Analytical balance, top loading balance, pH meter, what are their the readings, the measurements of those apparatus? So it depends. Since we have few types of different type of apparatus and instruments, so we tend to face some errors while doing the experiment, while doing any final year projects, right? So let's look at what types of errors that might occur during the experiment. So we have three types of errors: random or indeterminate errors. Random errors usually unpredictable, high or low. For example, pressure changes or temperature changes. So that is random error. So we are going to look at the example after this. And this random error can be handled by using statistical probability. Those that you learn in statistics class, it can be used to handle random error. And the second one is systematic errors. So systematic errors is divided into three type. We have instrumental errors, personal error, and method errors. And the last one, we have gross errors, which is another name for gross errors are human error. So what is the difference between personal error and human error under gross errors? Any anyone would like to share if you have idea what is the difference between personal errors under systematic errors and human error under the gross errors?
I think in systematic errors it's more towards like um when we salah kira or like salah measure, but when under human error it's more like we don't understand the topic fully, and when we do the experiment it's not correct because it's not the correct concept.
Okay, so let's look at in detail. Your friend just now, she share with us similar answers. Okay, but let's look at the real answer. Jawapan tu betul, tapi kita tengok contoh yang lebih jelas. Okay, so systematic errors, just now we have instrumental errors. Okay, it present in all measurement made in the same way and introduce bias. So first instrumental errors, we have bad calibration, for example, analytical balance. Sepatutnya calibration kita buat bila kita selalu guna, kita kena selalu juga buat calibration, tapi sometimes the personnel who in charge the analytical balance, dia tak ikut jadual. Okay, bad calibration or poor condition, poor environment condition where the instrument being placed. Okay, specific example here, electronic drift, temperature effects. So we have learned on temperature effect for volume measurement, right? So that is on the instrumental error. That error happened on the instrument itself. Okay, while personal error is the originate from judgment calls. Or for example, reading a scale or graduated pipette, titration endpoints. So this one, for example, just now we look at the burette. It is to the nearest of 0.01 milliliter. So while taking the reading, your judgment, your own judgment, saya nak sepatutnya 0.01 tapi you bagi jawapan 50.1. It's supposed to be 50.10, 2 decimal places. So that is the personal errors. Because when you take few decimal places, the final answer will be different from when you use more decimal places. Okay, suppose you use 2 decimal places, but when you use 1 decimal places, the final answer will be different. Okay, walaupun dia tak jauh beza, tapi in analytical chemistry, this will affect the accuracy. So that is personal error under systematic error. Okay, before we move to the method error, let's look at the example of gross errors. Just now it is on careless mistake or mistake in understanding. Sebenarnya you tak tahu pun burette tu kena baca 2 decimal places. Dia bukan, kalau personal error you dah tahu tapi you decide untuk ambil 1 decimal places. Gross errors you don't know, you ataupun you careless, patutnya you baca dulu manual tapi tak baca betul-betul. That is on human error, under gross errors. Okay. So offenses and outlier in the statistical distribution. Okay, nanti kita tengok outlier in calibration curve. Okay, we have, last time I said the best is 7 points, right? If you have any outlier, you can remove that one because minimum is 5 points. So biasanya calibration curve ni kita tengok we cannot judge immediately that is outlier. We have to do calculation using statistical methods to find the outlier. Sometimes we see that it is outlier because it is very far from the straight line. But bila kita buat kira-kira, oh tak jauh sangat beza, kita boleh terima dia. We can accept that point instead of outlier. So this one, under human error also, you didn't use the statistical methods to calculate the outlier. You judge it as an outlier. Okay, so that is the difference between human error and personal errors. Dua-dua melibatkan manusia tapi situasinya berbeza. Okay, this one is under systematic errors and that one is under gross error. So the last one under systematic error, we have method error. Okay, non-ideal chemical or physical behavior, evaporation, adsorption to surfaces, and you are handling easy to evaporate chemicals dekat tempat yang tak sesuai. Suppose you need to handle high concentrated acid in fume hood tapi you handle dekat luar. So the fume will affect other chemical near to that acid and it will give you error in measurement after that. Okay, adsorption to surfaces, some chemicals can be easily absorbed to surfaces. Then the method you use to handle that chemical is giving you the method errors. Okay, reagent degradation. So some reagent is easily to degrade if you don't store it in suitable storage room. So it will easily degrade and it will give you errors in final results. So that is method errors. Okay, so that is there are 2 types of errors just now, random error usually very high or very low changes in temperature, pressure, humidity. Okay, that is more towards the environment. And we have systematic error. Um, we divide the systematic error into three: instrumental error, personal error, and method errors. And the last errors is gross error, or sometimes known as human error. Okay, that is on type of errors. Now we look at the basic statistics in analytical chemistry, where we use this to calculate or to get more accurate and more precise results. Okay, so we have a basic statistics: mean, deviation, range, variance, standard deviation, relative standard deviation, and confidence interval. So these are the basic statistics that will be used in analytical chemistry. So last time you already learned on how to calculate those median, standard deviation during your statistics class. So I'm not going to go very detailed one by one. So kita akan terus guna sahaja dalam analytical chemistry. So for exercise, saya rasa tak perlu buat lah. You boleh tekan je calculator. For data 0.725, 0.756 and so on, you need to calculate the mean, median, standard deviation, variance, relative standard deviation, and range. So the equation will be given in appendix for test, for a final exam. Okay, your test will cover chapter 6 until 10. So for this one, it will be covered in final exam. So the equation will be given. You just insert all the data into the equation and get the mean, median, standard deviation, variance, relative standard deviation, and range. So yang ni, soalan ni straightforward. Soalan ni takkan macam ni lah. Biasanya kalau soalan macam ni keluar dalam quiz, objektif. Okay, but in final exam, we will give you a situation, and then you need to come up with the data and solve the problem given based on the question. Okay, biasanya kita tak minta lah you bagi, okay, kira standard deviation. Sometimes we are going to use the word precision. Okay, so precision, usually we look at the standard deviation, value of standard deviation. If the value of standard deviation is very low, so we can say that the results, the data is precise. Okay, so please be careful when you have lots of data. Okay, previously my students make mistake or very careless when there are so many data. Here we have 1, 2, 3, 4, 5. Okay, but sometimes they only take 4 data but divide by 5. Ataupun ambil 5 data tapi divide by 4. That is a careless mistake. Okay, so please be careful. Ramai yang hilang markah ni sebab careless, bukan dia tak faham. So be careful. And then when you look at the bottom here, when you calculate the precision or standard deviation, this standard deviation, it is able to control the random error, the first error. So if you want to reduce the random error, you need to calculate the precision or standard deviation. And if you get a very low standard deviation, means that you have a very high precision and you're able to control the random error. Okay. While for accuracy, it is ability to control the systematic error. Okay. So this is the answers. If you try to do it just now, hopefully you get the same answer with this. For mean, we have 0.749. Median, it is the one in the middle, 0.752. you need to rearrange the value from lowest to highest. So those in the middle is the median. What if you have another value here, 0.761? So which one is in the middle? How to calculate the median? Anyone? You need to unmute.
Doctor,
Yes.
plus the two middle numbers and then divide by 2.
Thank you very much. Okay, you need to uh, calculate the total of these two and divide by 2. So you get the median. Next is standard deviation. Use the equation or insert the data in your calculator. I think you know how to use the calculator to get the standard deviation straight away. So it is 0.014. Variance 1.898 times 10 to the power of -4. Relative standard deviation is standard deviation over mean, divide by mean. So you get 0.019. And the last one, range, it is the highest value minus the lowest value, we get the 0.035. Okay. So now we look at the application of statistics to data evaluation. Okay, what is the use of those statistics? Okay, the first one, when we want to reject an outliers. Okay, so outliers usually can be seen when you construct calibration curve, but we didn't go to that calibration curve yet. It is in chapter 5. So let's look at the previous example. Okay, so we have 5 values here. Okay, if you can see here, we have 0.725, which is very far from others. We have 5 here, 5, 5, and 6. But the first one is 0.725. It is quite far from others. And if we look at with our, if we just look at the data, we might guess it is as a outlier. Dia jauh daripada yang lain. Dia mungkin daripada kalau you still remember how to look at the accuracy and precision. Okay, the true value is on the line and we have another 5 values here. So this value quite far from others, 0.725 might be outliers. But we cannot judge without calculating using the statistics. Okay, so that's why this statistics is used to reject an outlier if it is outliers. So how to calculate that one, we are going to look at after this. Okay, there is a statistics equation on rejection of outliers, or we call it as Q-test. Okay, if you still remember, you have learned on T-test, okay, during the statistics class last time. I'm not sure whether you already learned on Q-test, but for rejection of outliers, we have Q-test equation. To define the confidence interval, what is the lower limit, upper limit? Okay, what is the acceptable interval? For example, if you run an experiment, kalau ada
0.5.
oh, siapa tu? Okay.
I think 0.95.
Which one? We already far away. I think. Siapa tu saya tak
That-
nampak.
That's CI. Confident.
Confidence.
Confident interval.
Yes.
I think acceptable is 0.95. or something like that.
Which question?
Nanti. Just ignore it.
Okay. I'm sorry because I cannot see who is speaking just now because I already used the slideshow, but it's okay. Let's move on. Okay. What does it mean by the confidence interval? Is the acceptable limit. Okay. For example, if you are doing testing. Okay. Saya takkan teruskan kalau saya rasa ada bunyi yang mengganggu kawan-kawan you. So I have to mute first. If you have question, please ask for permission so that saya tak mengganggu lecture saya.
Doctor, can I ask something?
Mm-hmm.
For analytical chemistry, do we have to draw box plot?
Sorry, what?
For analytical chemistry kan nanti kena lukis box plot tak?
Tak ada.
Okay.
Okay, Nur Marniliana. Dr. Aisyah same device with Marniliana. Okay. Runis. Yang ni masalah juga bila you share device, nanti attendance you tak ada lah. Okay, because it is auto collect using the Microsoft Team. Nanti saya fikirkan cara macam mana. Kalau before this saya bagi link untuk attendance, but since Microsoft Team automatic save your attendance, saya tak buatlah attendance yang tu. But there is problem when you share the device. Okay, Angie, I think that might be a problem for the attendance. Okay, Angie dah jawabkan. Thank you, Angie. Okay. Next, we are going to move to. Okay, we are going to continue. Just now, I'm talking about the confidence interval. Okay, let's say if you get samples from your customer. Okay, you are working in testing laboratory. Okay, you get sample from your customers and then you start to do the testing. Okay, so you have 5 samples, 5 same sample. Okay, and then for each sample you test for 3 times. Okay, and then you get the data, 15 data. Okay, from this data, you will calculate the confidence interval. What is the acceptable limit for those 15 data? Okay, the upper and lower limit, so near the true value or far from the true value. Okay, if you still remember the bell shape, okay, what is the acceptable limit? Okay, so that is defining the confidence interval. If the data is in the limit, you can give the results to your customer that their data is acceptable. If out from the confidence interval, you need to advise your customers whether they need to supply another sample or they want to reject one sample from the 5 samples given. Okay, depends on the customers. But you as a chemist, you need to advise your customer based on the results from the statistics data. Okay, next. Determination of number of replicate measurement required. Okay, so this one, if you have data just now, if you have sample just now, how many times you need to replicate the measurement? What is the best replication measurement for your sample? So we also have statistic equation to calculate the best replicate measurement. This one is in chapter 4. Okay, so we are going to look at the how to calculate the number of replicate measurement required based on your sample. Okay, next, we want to estimate the probability that an experimental mean and true value are different or that the two experiments are different. Okay, but this one is F-test. Okay, F-test kita tak cover. Okay, we only cover the three here, the Q-test, T-test and number of replicates. F-test kita tak cover. Okay, and also to treat the calibration data, this one is in chapter 5. Okay, so just now I'm talking about the Q-test and T-test, right? So this one used to reject and outliers. So this is the equation. Q experimental equal to gap over range. So you are going to reject if the Q experimental is greater than Q table. So if you already learned on T-test, you might be familiar with the student's T-table. Okay, T-table. Q-test, we also have Q-table. So from the Q-table, you need to compare with the Q experimental here, whether you need to reject the outliers or not. So you are going to reject only if the Q experimental that you calculate is greater than Q table. While for T-test, if you want to compare the measured results with a known value, or you want to compare the replicate measurement, and also you want to compare the individual differences. So if the T calculated is greater than T table, we know that the known value is different from the measured value. Okay, so this is the Q table. Okay, we have 90% confidence, 95 and 99%. This is the number of observation. If you have 3 data, so 3 number of observation, 4, this is the value of Q tables. And this one is the student T table. Those tables will be given in appendix for final exam. Okay, for T-test, we have from 50 up to 99.9 confident interval. Okay, it is quite different from Q table. So degree of freedom here, you still need to remember how to calculate the T-test. Okay, so that is on chapter 3. So I'm going to share with you the example of question on the Q-test and T-test after this. Okay, so any question before we move to chapter 4? Ataupun maybe you tak ada soalan lagi sebab tak nampak lagi contoh soalan. Doktor, sorry if I'm not contribute sometimes because Wi-Fi UMP buat hal. Okay, doktor. Slow. Oh, okay. So, ada yang bagi tahu saya slide start bergerak maybe because of the internet connection. You guys dah ada dekat UMP? Oh, yang okay. Yang boleh balik tu. Right. So that is on chapter 3. It is on the types of errors and basic statistics for analytical chemistry measurement. You need to decide whether to accept or reject the value. And we have Q-test and T-test, right? And also the number of replication in chapter 4 after this. So if there is no question, let's move on to chapter 4. And after this, we are going to look at the example of question for chapter 3 and 4. Okay, for those who have internet connection problem, you may refer to the recording after this. Okay. So chapter 4 is on sampling and sample preparation. Sampling is the process of collecting a representative sample for analysis. So steps in sampling is divided into 4. Okay, the first one is sample collection and sampling. You identify the primary sample and label the sample using handwritten. And then from the site where you do the sample collection, you need to
Mute. Mute.
Doctor mic tutup. Doctor, you muted.
saya mute. Saya baru mute ke saya mute dari tadi lagi ya?
Ada dalam beberapa saat.
Baru
Macam berapa saat macam tu.
Okey, saya tak tekan apa-apa pun. Okay, thank you. Right. So I'm talking about sample transportation and storage. Just now, after you collect the sample from on site, okay, you identify the sample by handwritten labels, and then transport the sample to the lab, put in a suitable storage, and again you need to identify the sample container with inedible ink. Okay, and then now after you have your sample in lab, you need to do sample preparation. So now you are going to use barcode, okay, for sample preparation. Yang ni dekat lab kita tak ada lagi sebab yang ni you are a student. So this one usually used when in industry. Okay, they have a system. So you need to use the barcode for automatic reading for sample preparation. And the last one, once you have done the sample preparation, you need to do measurement and report generation. And again, you need to apply the code number. Just now, code number for sample preparation. This one is code number for the report generation. Okay, this is for your information when you go to industry. Okay, now we move to the number of replicates. Okay, just now in chapter 3, we are using statistics for rejection of outliers, determine the confidence interval, and we have another one which is determination of number of replicates. What is the best number of replicates based on your sample? So we are using this equation. Okay, let R be the maximum allowable relative error, or usually we know it as a relative standard deviation. Okay, so R is standard relative standard deviation. So the equation is R relative standard deviation times mean equal to the T, the value of T from student table, times standard deviation over number of sample, the square root of number of sample n. Okay, let's see the example of question. Okay, in production process, a method for determination of concentration, the reagent A concentration in a formulation give 4.3 plus minus 0.30% by weight, okay, weight over weight. So that is the concentration of reagent A. Okay, if the process require that the formulation be within 5% of the stated concentration, how many trials or replicates should be done on each batch to ensure that the prescribed limits are attained with a 95% confidence? Okay, kalau you guys baca ni memang mula-mula memang tak faham lah apa yang dia nak. Okay, but the main thing here is that the question asks you to calculate how many trials or replicate. So we know that if we want to calculate the number of replicate, we are going to use the equation R times mean equal to TS over square root of n. Okay, so the value are given, but still we don't know which one is which, right? So this within 5% is the relative standard error. Okay, because if you read again and again, so you know that this is actually the relative standard deviation, R, but it is given in percent. Please remember that this R, when you want to insert into the equation, you need to use the value of 0.05, not in the percentage. Okay, so you are given the concentration of reagent A, 4.3 plus minus 0.3. So this one is mean. Kalau you ingat statistics, this one is mean, plus minus is standard deviation. Saya tak nak ulang balik lah yang ni. Kalau you lupa, you kena buka balik nota statistics. So 4.3 is the true value or mean, plus minus 0.3, which is the uncertainty or standard deviation. Okay, so we already have R value, S value, and this 95% confidence refers to T table. Okay. So we need to find this n, number of replicates. So first you need to rearrange the equation. You want to find n. So you need to rearrange TS over R mean square. Okay. Sampai sini boleh faham tak? Ke saya laju sangat ke? Ada yang tak dapat nak catch up? Okay, so no question. First, when you get this kind of question, baca betul-betul, determine which one is mean, which one is standard deviation, which one is the relative standard deviation, and remember relative standard deviation, if given in percentage, you need to use the value 0.05. If given in 0.05, you can straight away use. Okay. When you read the question, if the question asks you how many trials, straight away use the equation for number of replicates. Okay, and then you need to rearrange the equation to find the value of n trials. Okay, this is the table, students T table. We need to find on 95% confidence interval. So what is our degree of freedom? Okay. So this is the answer. Okay, this is the equation. First, when you already come up with a value for each of the R mean here, what is the value of T for the first time to calculate the number of n? Okay, you need to assume. Okay, you need to assume that n is equal to infinity. For the first time to calculate this one, okay, you need to assume n is equal to infinity. So look at the T table here. At 95% confidence, n equal to infinity, the value is 1.96. Okay, sebab kita tak tahu lagi n berapa, so kita assume n is equal to infinity. So at 95% confidence interval, it is 1.96. So now you already have the value of R, mean, standard deviation, and T. Insert in the equation. Okay, TS over R X bar square, you get the value of N. Okay, so please try now so that you can see how to calculate the this question, and let's see whether our answer is the same or not. Okay. So for the first one, 1.96 times 0.3 divide by 0.05 times 4.3. Okay. Square. Do you get 7? The value of 7?
Yes.
Okay.
7.5
7 point?
or 9 or 7.
Okay, so 7.4 we assume that it is equal to 7. Okay, 7.4 kita ambil 7 lah. Okay, now you already have n equal to 7. Okay, bila nak berhenti? Okay, bila nak berhenti? Bila you dah dapat value of n is constant. Okay, bila you dapat, kalau you nak nampak kat sini jawapan dia 10. Bila you dah dapat 10 sekali, the next you try to calculate again and you get 10. Dah 2 kali tu maksudnya you akan dapat sama lah nanti, sebab when you get n equal to 10, the t value will be the same. So kat sini dah boleh stop. Okay, for the first time, we assume n equal to infinity, we get t equal to 1.96. Bila you masukkan, you dapat the first n is equal to 7. So from this n equal to 7, go back to the student t table. Look at the value of t when you have n equal to 7. It is 2.365. Okay, the new value of t is 2.365. So now, the second, to calculate the second one, you need to change t equal to 2.365. Insert in the equation here, you are going to get the new value of n. Okay, kalau you masukkan, sepatutnya you dapat the second one, n equal to 11. Is it the same?
Yes.
Okay.
Yes. Tapi the jawapan dia like 10 point something.
10 point berapa?
10.8
10.8 kita bundakan jadi 11 lah. Tadi 7.4 kita ambil 7. Unless 7.5. Kalau 7.4 kita ambil 7. 10.8 kita ambil 11. Okay. So the second one, n equal to 11. Look at the student t. Okay, kalau you tengok kat sini, ni yang dot ni maksudnya 11 sampai 14 lah. Okay, so 11 sampai 14 dia akan guna value yang sama dengan 10. Okay, so 11 we have 2.228. Okay, so 2.228. The second t, or just now we assume as infinity. Okay, first n is 7, we get the first t 2.365. The second t is 2.228. Okay, now calculate again the number of n using the new t. You're supposed to get 10.
Yes, 10.
Okay, so you get 10. Now t is equal to 2.228 because they are the same. Okay. Once you get this one, you insert again in the equation, you will get again n equal to 10. So bila dah dapat 2 kali macam ni dah boleh stop lah. So the number of trial or number of replicates is equal to 10. So you need to do 10 times replicate your measurement. Kalau buat titration tu kena buat 10 kali. Okay. But this is different. This is not titration. Titration lain. Ini sampel yang dekat production line yang industri besar-besar tu memang banyak kalilah trial sebab number of sample dia pun banyak. Okay. So that is on number of replicates. Kalau titration dekat lab 3 kali cukup lah. Okay. Sampling techniques. Okay, we need to consider a few number of factors when doing the sampling techniques. First, we need to know the chemistry of the materials. Okay, organic materials ke, inorganic ke, dia mudah meruap ke. Okay, you need to know the chemistry of the materials because different sampling technique will be used for different chemistry types of material. Organic material cara dia lain, inorganic lain. Organic, for example, if you are sampling fragrance, essential oil. Okay, you want to do extraction of essential oil, so you do sampling on the plant, for example lavender. So that is different when you do sampling for soil. Okay, so that is chemistry of material. It depends on chemistry of the materials. And the next one, the size of the bulk sample. Kalau you ada 1 ton sampel dengan 1 kg, okay, cara untuk sampling dia berbeza. Okay. And the last one, it depends also on the physical state of the sample, whether they are liquid, solid, gas. So we have different sampling techniques. So we go to the example of sampling technique, which is very common use in industry, corn and quarter method. Even though this corn and quarter method is very traditional, but it is very useful in industry because they have so many banyak sangat sampel. Okay, so dia kena guna corn and quarter method. I'm going to share the video on how they do this corn and quarter method in Kalam later on. Okay, you can see how they do it, but in words, okay, we can say that the logical steps in corn and quarter sampling method is by dividing the pile of material into quarters. Okay, you have, you bayangkan you ada soil sample, okay, 1 guni, okay, 1 guni soil sample. You divide the soil sample into quarters, 4 parts. Okay, yang ni you boleh agak-agak je dulu. Okay, since it is very difficult to divide a few tons of sample pile, so you just do it agak-agak dulu, sama banyak quarters for divide into 4, and then take samples from each quarter of the pile. Okay, crush these samples and form into a smaller conical pile. Okay, dah ambil satu, letak dalam bentuk conical pile, flatten the conical pile and cut into equal quarters. Again, divide by 4, and the 2 opposite quarters are chosen at random. Okay, contoh dia macam ni. Okay, you ada 1 guni, tadi soil sample. Okay, divide by 4. Tak nampak lah, kalau 3D nampak, nanti you tengok dalam video. Okay, after that, take each parts ni. Okay, ambil satu-satu, buat lagi dalam bentuk conical pile, and then divide into 4 again. So dah divide into 4, yang ni take 2 opposite quarters, this one and this one. Okay. Choose at random. Crush the quarter further. Mix it thoroughly and repile. Okay. Dah ambil dua ni, mix. Lepas tu buat lagi sampai you dapat the ideal mass of sample to do the experiment. Tengoklah kalau lab you kecil, sikit lah dia punya last final mass tu. Okay, kalau lab you besar, ada sample container besar, dia punya mass tu tinggi. This one is depends on the type of sample, type of industry, type of sample container use. Okay, nanti you tengok dalam video. Okay. Homogenization of samples. Once you have a sample, you do sampling, you have done sample preparation, you need to homogenize the sample. Okay, macam yang tadi kita buat, kita campur daripada satu guni, kita buat quarters and then we mix each of them, we mix the opposite one. It is to homogenize the sample. Okay, to mix them well. One of the treatment for a solid sample is homogenization. It is suitable for solid sample. This can be carried out by crushing, pulvering, grinding, okay, or rendering it into a thoroughly mixed powder. One of them is in the cone and quarter methods. Okay. Sample should contain large number of particles because variation in content between individual samples is minimized. Each sample should be more representative of the material. Okay, what does it mean by sample should contain large number of particles? Okay, for example, if you go to a site, okay, you want to sampling soil sample, okay, if you sampling here, it might contain high amount of iron. Okay, if you do sampling here, it might contain low iron. So you need to do homogenization and the sample should contain large number of particles because it will minimize the variation. Okay, if you sampling here, you get high amount of iron, but if you sampling here, you get low amount of iron. You need to homogenize, mix them well to reduce the variation in content. Okay, so that each sample representative of the iron here. Okay, and then sample integrity. So sample integrity, for example, just now, to make sure you get you have high content of your target analyte, you need to consider factors that affect the sample integrity. For example, time. Okay, time here, when you transport the sample from on-site to the lab, okay, it takes times, right? So you need to know whether your sample integrity or your sample concentration will be degrade or not during the transportation, okay, because it requires time. Okay, and you need to also consider the temperature. High temperature might degrade your sample. Okay, what is the suitable sample to store your the suitable temperature to store your sample? Okay, what is the optimum temperature? Depends on the type of sample. Humidity level is the same. Okay, sample acidity, oxygen content, exposure to light. Some sample cannot be directly exposed to light, so you need to use a special container. Okay, kalau you perasan kita ada macam-macam jenis botol container kan. Ada yang colourless, ada yang brown in colour. So that brown in colour is to be used by sample which sensitive to light. Dia mudah degrade kalau kena cahaya. So kita guna brown bottle. Okay. So and the last one, selection of container must not contribute interference and absorb analyte significantly. Okay, some container ada yang boleh guna glass, ada yang kena guna glass, ada yang boleh guna plastik. okay, some plastic will contribute interference. Okay, kalau kena acid, contoh kalau you storage your acids in plastic container, okay, acid tu menghakis, so it will contribute interference to your acid just now. Bila you nak guna nanti untuk eksperimen, tak dapat results yang betul. So selection of container also contribute to the sample integrity. Okay, physical separation on sampling. Okay, this is only a few example. Okay, you can get more example using references, okay, books. And here I'm only sharing with you some of the example. Okay, physical separation. If you have solid sample and you want to separate solid material from this solid sample, contoh dia, kalau you nak asingkan apa okay, you ada batu kecil, okay, very small, batu-batu kecil dekat pasir tu, okay, dalam tanah. Okay, tanah tu solid, batu pun solid, tapi sebab dia kecil, so you have to use a suitable separation method. Okay, if you want to separate solid from solid, you need to use density flotation method or solubility differences. Okay, if you want to separate liquid from solid, you can use heat and trap method. Okay, while if you want to separate gas from solid, you can melt the solid and you can get the gas by purging the gas. Okay, if you want to separate solid from liquid, you can use filtration. This is very straightforward. Either you want to use the filter paper or you want to use the vacuum pump. Okay, liquid from liquid, you can use distillation method. Kalau you dah buat eksperimen organic chemistry, okay, you want you use the liquid extraction, that is distillation, and we also have Soclap extraction, that one also use the distillation method. Okay, gas from liquid by purging and trapping or using the gas permeable membranes. Okay, if you want to separate solid from gas, it is by filtration, liquid from gas by filtration as well, but now you remove the liquid aerosols, and gas from gas by differential diffusion or selective freezing. This one, if you want a very detailed, you cannot imagine how they do it, you can go to YouTube and type the method. Tapi yang ni tak perlu hafal lah, tak perlu elaborate. Biasanya kalau soalan tu saya tanya how you separate liquid from solid. Okay, jawapan dia by heat and trap pun dah dikira betul. Okay, no need to be very details. Okay, type of sample, we know that we have gas, liquid and solid sample. So different samples require different technique. Okay, sampling technique. Okay, if you can see here, the gas sample is in blue color, liquid sample in red color and solid sample in orange color. So here I divided them based on the type of sample. So if you have gas sample, you need to use sampling bag. Okay, so the principle of technique, you need to fill a plastic bag or the sampling bag with ambient air, seal the bag and transport the sample to the lab. So the gas can be used directly. This one is using sampling bag. If you have liquid sample, you need to do the centrifugation. So the sample is placed in a tap centrifugation tube and spun at high force and forced to the bottom of the tube. So the liquid will be decanted. It is slow because it depends on the settling rate. Okay, and at the end you will get the liquid sample. For solid sample, you can use dissolution, or this one is classical methods, or modern methods we have accelerated solvent extraction. Okay. So the principle of technique for dissolution, yang ni you dah biasa buat lah dekat lab. Kalau you dah masuk lab, you dah ataupun you guna labster tu, you boleh nampak lah. Dissolution is very straightforward. A solid sample is dissolved in solvent without chemical change. Okay, they don't react with the solvent. That is what it mean by chemical without chemical change. You dissolve the solid into solvent without any changes or any reaction. So inorganic solid may require acid or base to enhance the solvation. So usually if you want to get an inorganic solid, you require acid or base. Okay, and some sample require heat to do the extraction method. Okay, and for modern method, we have accelerated solvent extraction. It means that you pressurize the liquid for liquid extraction. Okay, solid sample is placed in sealed container and heat to its above its boiling point. So extracted analyte is removed and transferred to vial for further treatment. Okay, that is the difference between classical method and modern methods for solid sample. Okay. If you do sampling, you have a different type of sample. Of course, you will deal with a sample matrix or interference. And this sample matrix can be divided into two. We have organic matrix or inorganic matrix. And the organic matrix can be further divided into volatile, volatile interference, semi-volatile, non-volatile, or biological samples. So that is only a general introduction on type of sample. The details one, okay, contoh kalau you ada volatile matrix, how you want to reduce this sample matrix, that one will be further explained in second year, separation techniques. Yang tu detail lah. Sekarang saya nak perkenalkan you guys yang kita ada beberapa jenis interference that might interfere in our samples. So that is the end of chapter 4.